Hello students, welcome to the Unit 8 Notes, Section 10.6. For your warm-up today, if you want to try this on your own, you can. Just pause the YouTube video, but in a second I will start to label this circle so that you have the correct answers. Well, the first one here, that's probably the easiest, is the center. We'll label arc next. So here's an arc. Notice there's a lot of arcs. So this isn't the only arc. There's this arc here. There's also another arc here, another arc here, another arc here, and then an arc there. So that's just one arc. Radius. Well, here we have three radiuses, or three radii. I'll label this one right here, just so that it doesn't interfere. Now remember, radius is equidistant from the center to the edge of the circle. So these are all congruent. The reason why I left the other two out is because I want to label this one a diameter right here. I'll label this whole one a diameter. Let me try that again. All right. So next is a chord. A chord goes from edge to edge of a circle. The largest chord in any circle is actually the diameter. So the diameter, again, largest chord in any circle. But there can be an endless amount of chords in circles. Let me change some of these colors to match. Arc and center. I'll change to, and there we go. Secant line. Let's do secant line next. A secant line goes through, it's kind of like a chord, but it's a line, so it goes on forever. So it's just a line that has two intersections with a circle. So this one right here is a secant line. That pretty much leaves tangent line and tangent point to the end here. A tangent line touches the circle in only one spot, as you can see here. So this line is our tangent line. Making this last piece here, I'm running out of colors. Let's do, whoops. Making this the point of tangency or the tangent point. We're going to be using all of these items, so you will need to know what they all look like, and we'll be exploring them more. So 10.6 is circles and arcs. We talked about all of those things above. One thing that we haven't talked about yet is congruent circles. So congruent circles are all circles that have congruent radii. So in this case, if I were to try to make a circle here, that's about, yep, so that these circles are congruent. In this case, we would label a radii, and we would draw it like that. And so now we know that circle P is congruent to circle R. The notation for this is circle P congruent to circle R. All right. Central angle. Here is a central angle. Oops. Central angle. Oh, they already have it listed. Central angle CPA. The central angle goes through the center. Here's what's really cool. We're going to start to focus on it. This is what we call an intercepted arc. So CA is an intercepted arc. And what's unique about this is that if the central angle, I don't know, let's say that that was 40 degrees. I'm just approximating. Say it's 40 degrees. The circle also has an intercepted arc of 40 degrees. So not only does a circle's central angles add up to 360 degrees, but also its arcs add up to 360 degrees as an arc measure. So let's talk about those measures of an arc. Notice how the notation, I like to put a degree measure here. So the measure of semicircle TRS is 180 degrees. So TRS, arc TRS, has a 180 degree measure. It's not a length, it's not a distance. It's not like you're walking around the edge of your pool. It is, the edge itself is just represented as a degree measure. TRS is a semicircle. RS here is a minor arc. The reason being is because minor arcs are less than 180 degrees. Okay, so it says a minor arc is smaller than a semicircle. We're going to say that it's less than 180 degrees. So in this case, I don't know what that is. Let's say it was 135 degrees. I'm approximating again. So we would just say the measure of arc, RS. Oops, it's kind of like a arc for a hat, is 135 degrees. Again, I'm just approximating this one. So not only is the measure of the arc 135 degrees, but then the measure of the central angle would also be 135 degrees. And then here we have the other side. So we have the measure of arc, RTS, and this is a major arc. A major arc because it's more than 180 degrees. So minor arcs, I guess we can put a little note up here. Minor arc is less than 180. A semicircle is equal to 180 degrees. And then a major arc is greater than 180 degrees. So if I want to define this, well, I know that this arc is 135 degrees, so I could do some algebra. 360, take away 135. So 3, 260, 50, 40, 30, 25 degrees. So here we have 225 degrees. So the measure of arc RTS, RTS is 225 degrees. Now, if we zoom out on this whole big picture, some of these arcs use 3 letters, like a semicircle and a major arc, and some of them only use 2 letters. And the question is, why would one use 2 and why would one use 3? Well, for a minor arc, we always use 2 letters because it's talking about if you were to travel from R to S, it's talking about going literally from R to S in the shortest direction possible. Whereas a major arc, you have to tell the reader where they're going. They're going from R in the direction of T, and then they finally conclude at S. When talking about a semicircle, you want to kind of just say TS, but you have to tell the reader, am I going from T to S this way, or am I going from T to S this way? So direction is important when we're talking about 180 degrees or more. So again, minor arc, always use 2 letters. Major arc and semicircles always use 3 letters because even though it's 180 for a semicircle, you don't really know what direction you're going in unless you put a letter in between to describe the direction you're traveling around that circle. Adjacent arcs, to make them as simple as possible, they're arcs that lie side by side. So in this case, arc RS and arc RTS are adjacent arcs. Okay, they have exactly 1 point in common. Oh, I'm sorry, they have 1 point in common. So it can't go around the whole circle. But here is, let's focus on this one. So arc AB and arc BC are adjacent arcs. So they share one, have exactly 1 point in common. Okay, the arc addition postulate. Again, something pretty simple and self-explanatory. If this arc is, I don't know, I'm going to make up a 50 degree. That's probably not right, but and this one is 130 degrees, then when we add them together, 50 degrees plus 30 degrees, oh, I'm sorry, what did I do? 130. Oops. Then we get a total of 180 degrees. So these arcs are, if you add them together, that's the arc addition postulate. So the measure of arc ABC is equal to the measure of arc AB plus the measure of arc AC. Notice that they use 3 letters for the measure of arc ABC, so I made the assumption that it was 180 degrees or more. And you know what? It looks like it's more than 180. So let me just make this one 140. Yeah, by appearance, it looks like it's a little bit more than that. So I'm just gonna, just so it doesn't look like they always add up to 180. No, they can add up to whatever they need to when we put them together, but there we go. So we're just going to add the arcs together for the arc addition postulate. All right, example 1. So here we have to know that sometimes circles are given in degree measure. Other times they could be like a pie chart and be given to us in a percentage. So in this case, we have percentages, and they're going to add up to 100%, not 360 degrees. So to convert this, if you're ever given it, you just multiply by the appropriate amount. So sleep, what we're going to do is for sleep, it's 31%. So I'm going to say that 31%, if we want to find the measure in degrees of the central angle or the arc, we're going to take 31 out of 100 and multiply that by 360 degrees because it's 31% of 360 degrees. And I'm going to do that for all of those. To save time on this video, I'm just going to do them very quickly. And I'm just going to change the number out of 100. So sleep is 31. Food is 9. Work is 20. Must do is 7. Entertainment is 18. And other is 15. I have my calculator with me, so I'll do the work real quick. 360 times 31 divided by 100 is 111.6 degrees. 9 out of 100 times 360 is 32.4 degrees. Work, 20 out of 100 times 36 is 7.2 degrees. Must do is 36 times 7 divided by 100. We have 25.2 degrees. 18 out of 100 times 360 is 64.8 degrees. And 15 out of 100 times 360 is 54 degrees. Whoops. I'm going to check my math, make sure I did it right. So if I add all of these together, I know what you're thinking, Mr. A, the amount should be 360 degrees. So 111.6 plus 32.4 plus 7.2 plus 25.2 plus 64.8 plus 54. Did I miss something? 2, 4, 6. 15. Food is 9. Work is 20. Must do is 7. Entertainment is 18. And other is 15. I must have missed something when I added. Let's try this again. 111.6 plus 32.4 plus 7.2 plus 25.2 plus 64.8 plus 54. I am not getting 360 degrees. What did I do wrong? 31 times. I'm going to check over all my work. Found it. Work. I must have done 2 tenths. Be careful, be careful. Even math teachers make mistakes. This should be 72 degrees. I'm so glad I checked over my work. 111.6 plus 32.4 plus 72 degrees, not 7.2, plus 25.2 plus 64 plus 54. Point 8, yeah, plus 0.8, good, 360 degrees, awesome. Oops. All right, hopefully I didn't confuse you on that one, but everything checks out to be 360 degrees total. Next, moving on to example 2, identifying arcs. Let's identify all of them, all the minor ones. It appears that all of these are minor when we keep them separate. So we have arc AC, arc CE. Again, these are all less than 180 degrees. Arc ED and arc DA. The semicircles appear to be DAC, DAC, ACE, and I guess we can repeat them. ADE is the same as EDA, so really, these are the only 2 unique semicircles that we have. But in repetition, we could say EDA. Wait, I'm sorry. DAC, ACE, EDA is actually on the other side. My apologies. EDA. This is unique. And DAC is unique as well. What I meant to say was DAC. Oh, wait. I said DAC. DAC, ACE, CED, CED. Going in order. So CED and then EDA. These are all unique. If you were to switch EDA to ADE and just switch the two letters at the end, that's the same arc. So let's not repeat that because that would just be, it's the same arc and it's not unique. The major arcs that contain point A, what we have to do is we just have to go a little bit further. We can't do a semicircle. We have to go further and include that. So this one's going to take a second. I'll move them over to where they belong afterwards, but it's easier to see them here. We have arc ACD, that could be one. ACD, we have arc ADC, that's another. We could do maybe DAE, and we can do, let me see, DAE, and then CAE. I think this might be all of them. All right. So, on a quiz, we probably won't say, list all. We might say which of the following are, but you never know how it might be written. Might be check all that apply. All right. Identify the four major arcs of circle O that contain point E. So the four major arcs that contain point E, again, these are going to be kind of the same style that we did before. We'll do EDC, arc EDC, arc ECD, and then arc DEA, and arc CDEA and CEA. I think those could be it. All right. Hopefully that made sense. Feel free to pause these videos at any time to kind of catch up with the work if I'm going fast. I just want to limit the time of the video. Find the measures of each arc. When I get a problem like this, I tend to go a little bit to the extreme. I try to fill all the information in and then answer the questions. So here's my suggestion. Just go around the circle and fill in the pieces that you want to fill in. So if angle O is 32 degrees, COB, then arc CB is also 32 degrees. If this is 58, then this is also 58. And then I have two unique situations here. I have what appears to be a diameter. I know that a diameter is 180 degrees. So it divides the circle into two semicircles. So I'm going to do 180, take away 58, 58, and I will get, that's 122 degrees. So this arc is 122 degrees, and so is this angle here, 122. And then I'm going to do this work again, and I'm going to do 180, take away 32 degrees, and so I get 148. So this is 148 degrees, and this arc is 148 degrees. Now that I have everything there, I go back and I'm going to answer these questions. I just think it's a little bit easier. So BC is 32 degrees. Oops. Do me a favor. Throw the measure out front here. It really should be, we should be writing it like this. Measure of BC, because it's a measure. So 32 degrees. Measure of BD, of arc BD. BD is, BD, look at, that's unique. So it wants me to add those together. It wants me to use the arc addition postulate. So 32 plus 58. So measure of arc BD is not, it appears to be 90. All right. Measure of arc ABC Looks like I'm going to have to add a couple things together for that one. Yeah, it looks like it's 148 and 32, which we know is that's AC is a diameter, so it's going to be 180 plus 32. So measure of arc ABC is 180 degrees. The last one, measure of AB is 148 degrees. You know what? I don't want you to get confused with the coloring here. I'm just going to change this all over to a color I didn't use because they're not correlated to anything. All right, and I will now answer these down here. So the measure of COD, the measure of angle COD is equal to 58. The measure of, CDA, CDA is 180. That's a semicircle right there. Measure of AD, measure of arc AD is 122. And measure of BAD, arc BAD, not too bad, is 148 plus 122. So that measure of BAD is 282.90, I believe, if I did that right. BAD is 148 and 122. So that's not 290. That's 260, 270 degrees. Okay. Now at this point, I'm done with the lesson, but because of our unique circumstance, I'm going to continue on with the notes exercises. At this point, you don't have to watch. I do want you to do these as practice for your tests that you'll eventually have. But remember, your IXL assignments are the ones that are due. I just figured, let's see how long this is. You know what? I'll answer questions in class for numbers one in our Google Meet live, but I think you should be able to do all of these numbers just fine. But let's focus maybe just on numbers 52 and 53. So in this case, when given a variable, what we notice here is that we have a diameter. So what I would do is seeing as a diameter is 180 degrees, I would say C plus 4C minus 10 equals 180. So now you get 5C minus 10 equals 180. Let's add 10 to both sides. We get 5C equals 190. So I believe C is 38. Let me just check. 190 divided by 5, yep, is 38 degrees. So C is going to be 38 degrees. And it said find the value of each variable. So I am done. It didn't ask me to find any arc or angle. So my answer is just in the variable. I could check my work by evaluating it, and I did it quickly in my head. 38 is correct. The next one is the variable x, but notice it's the whole circle, and the whole circle adds up to 360. So you can do that one. Just go around the circle, add everything together, and collectively set it equal to 360 degrees. And it appears that 3, 4, 5, 6x plus 60, 100, 120 equals 360 degrees. So we'll take away 120 from both sides. 6x equals 240. So x should be equal to 40. And we can check our work. 6 times 40 plus 120 is equal to the 360. So we are good. I think those are the only problems. Let me just look through the worksheet. Yeah, so you should be all set now for all of lesson 10.6. Make sure you do, again, all of this worksheet, all of these questions, and then you can start your IXL assignments. Again, the IXL won't cover everything that's on the test, so it truly is very important that you do the notes 10.6 questions and the practice 10.6 and the answers I have posted to Google Classroom. Okay, see you later.